Hey guys, this is Mr. C here, and today I'm going to show you a little video about how to graph quadratic functions that are in standard form. If we remember from some of our previous lessons, standard form of a quadratic looks like this. F of x is equal to ax squared plus bx plus c. All right. This is not really helpful in graphing because all of this has been expanded and I don't really know where the vertex is right now. I can't find it easily. And many times this is how you're going to get these quadratic functions given to you. I mean, and I hate to say it, it's just about every time when you get up to Algebra 2 and beyond. We are used to seeing it like this though in vertex form. F of x is equal to a times x minus h squared plus k. We're really used to that. And this is really handy to graph because we can find the vertex easily. The vertex is going to be just at h, comma, k. And so we had a really easy time graphing these, but now it's going to be a little bit tougher. And so how do we find the vertex here without having to do all this? And then I will actually show you a couple different ways. Well, here's what it is. The vertex is going to be, for this form, at negative b over 2a, comma, f of negative b over 2a. And so the question that you're going to have is, how do these things come about? How do you get negative b over 2a and f of negative b over 2a? I mean, where do these even come from? I mean, is this something I just came up with? I have no idea. Well, the good news is we already know something about the quadratic formula. The quadratic formula, if you guys remember, is x is equal to opposite b plus or minus square root b squared minus 4ac, and all of that is over 2a. So the first thing you notice, and people are really good at noticing things, especially patterns, we're built for it. You see a negative b over 2a right here. Well, maybe there's a coincidence, or maybe not, that this negative b over 2a and this negative b over 2a are related. Well, let's go ahead and take this, which actually represents where it crosses the x-axis, the two places, and let's go ahead and break this up into two separate fractions. And we could do that by saying opposite b over 2a plus or minus the square root of b squared minus 4ac over 2a. So now things are going to be a little bit clearer. We have this piece right here, and then we have this piece right here. This piece is going to represent the vertex x coordinate, and that's also the axis of symmetry. And so if you remember, for a quadratic function, and let's just say it looks like, the graph looks like this, and let's say it crosses here and here on the graph. These two places right here represent these little pieces that are this far away and this far away from that axis of symmetry right there. Well, if this is the axis of symmetry, then this gives you those two little pieces right there that are on opposite sides of it, because it's plus and minus the same exact number, right? And so we can kind of now make some connections. So if we can figure out the negative b over 2a part, which is really pretty simple, we can actually get the x coordinate of the vertex really easy. All right, so we're going to start there. After we do that, we're going to plug that value into the function for the x here and the x here, and then we're going to have to do a little bit of simplifying, and then we'll get the y coordinate. All right, because that's how you find the vertex of any quadratic no matter what anyway. You just plug the x value in, you get the corresponding y value. And really that's true of any function. When you plug the x value in, you get the corresponding y value of that point. So let's go ahead and see how one of these works. The first example I've got for you is f of x is equal to x squared plus 2x minus 3. Okay, so there's my quadratic in standard form. My a is 1, my b is 2, my c is negative 3. A, B, C. Make sure you look at the signs, because if you miss one, then you're going to get the whole thing wrong. All right. So now we're going to calculate negative b over 2a. I always put the negative on top in the numerator. You can put it here or down below. I always put it here because that's just my habit. So I have opposite b, which is 2, over 2 times a, which is 1. Okay? So we're going to simplify that. Well, negative 2 over 2 would be negative 1. And when you multiply by 1, nothing happens. So this whole thing is really just going to be negative 1. We're going to take that negative 1 now and plug it back in here and plug it back in here to get the corresponding y value of our vertex. So we want f of negative 1. And that's going to be negative 1 squared plus 2 times negative 1 minus 3. Now notice that I've used parentheses. Use parentheses because people get into big trouble when they don't use parentheses, especially with negative numbers. All right, so let's see how this works. Negative 1 squared is really just positive 1. A positive 2 and a negative 1, when you multiply them, will give you negative 2 minus 3. 1 minus 2 is negative 1 minus 3. And negative 1 minus 3 is actually going to be a negative 4. So we have found our vertex, and our vertex is going to be at negative 1 comma negative 4. Now, again, this is just a process. It's very simple, and it just takes maybe 20, 30 seconds to do this. Just pay attention to what you're doing. You should have no problem. Now, let's take a look and see what that graph would look like. So now we have our vertex at negative 1, negative 4. So here's negative 1, negative 1, 2, 3, 4. Okay? I've looked at my a value. My a was 1, which means even with the same thing with the quadratics and vertex form, if your a is 1, it's going to be business as usual. Over 1 up 1, over 2 up 1, 2, 3, 4, over 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you could sneak another one in, it'd be up 16, but you usually don't get graphs that large unless you use a piece of graph paper. Axis of symmetry is here. So on the other side, I've got this guy and I've got this one. And that's my pattern. Go ahead and connect my dots using a smooth curve. And it's not really dashed. I just do this because I have kind of a hard time making it look good without it. And there's my parabola. Very simple. What if I don't want to do it this way? And again, the big thing here is finding the vertex, because the whole thing's about the vertex. So how do I find the vertex a different way if I don't like doing this or I don't remember doing this? Well, if you're good at completing the square, which amazingly, some people really enjoy that, which is great, we can complete the square and we can get the vertex the same way. So let's complete the square here just to kind of refresh our memory. So if we complete the square, and I'll just write it again, f of x is equal to x squared plus 2x minus 3. Okay, if we do that, remember, these two terms get separated from the negative 3. X squared plus 2x. And I believe we left a plus blank in there. Minus 3. And since we're adding a blank here, we need to subtract the blank at the end. The same exact number. To find out the number that goes in the blank, we took this number, divided it by 2. Every time it's divided by 2. That's no coincidence. And we square it. 2 over 2 is 1. And 1 squared is 1. That number goes here and here. Okay? Now, we have a perfect square. This is now a perfect square. And that's going to be x, if you remember x, plus 1, this one, squared. And negative 3 and a negative 1 are going to make a negative 4 at the end. And now we're in vertex form like we've done many, many times. Our vertex is opposite 1, comma, negative 4. And clearly, we got the same vertex both times. Again, once you get the vertex, you can use your A value, and you can just go over 1 up 1, over 2 up 4, and the graph is very, very simple. All right, so that's example number 1, and you're going to get a lot of those in Algebra 1, and some in Algebra 2. Okay, so let's look at our next example. Our next one is f of x is equal to 2x squared minus 4x minus 1. So now we have an a value of 2, because you need to see what happens when that a value changes. So now we're going to do the same thing, opposite b over 2a, which is going to give us opposite negative 4. I'm using parentheses because if I don't, I'm going to run into some serious trouble, over 2 times 2 times 2, because a is 2. Okay, now let's see what that does. Negative, negative makes positive when they're side by side. 2 times 2 is 4. And so I just get a 1 right for this one. That's my x coordinate of the vertex. I'm going to plug that back in here and here to get my y value, my y coordinate. So f of 1 is equal to 2 times 1 squared minus 4 times 1 minus 1. All right, so now we have to simplify this. 1 squared is 1, right? 1 times 2 would be 2. Negative 4 times 1 is negative 4, and then a minus 1 at the end. 2 minus 4 is negative 2, still minus 1, and negative 2 take away 1 is negative 3. So now we have our vertex, and our vertex is going to be at 1, comma, negative 3. Okay, so what would the graph of this one look like? So this time, we have 1, negative 3 for our vertex. So 1, negative 2, negative 3 right there. But this time we have an a value of 2. So we used to go over 1 up 1, right? But now all my y values are going to get multiplied by 2. So it's over 1 up 1 times 2, which is 2. And we know from experience that this a value, since it's bigger than 1, is going to make the graph narrower. It used to be over 2 up 4, right? But now you've got to multiply that by 2. So now it's 2 up 1, 2, 3, 4, 5, 6, 7, 8. It used to be over 3 up 9, but now that would be 18, and that's going to be way off my graph, so I can't get that point in. So axis of symmetry on the other side. Okay, and we see the pattern has definitely narrowed. And so now we'll connect our dots the best we can. And there it is. So still not too hard, even when you have a 2 out front, still not that difficult if you use this method. And again, let's say we don't like this for some reason. We want to go ahead and complete the square, which is really not a bad idea, because when students get into college, they have to do this all the time. And if they avoided it in high school, they have a really tough problem then, because now they have to use it for a bunch of other things, and they have to learn it quickly. So it pays to kind of get a hold of it now and then refresh your memory later. All right, so let's see what this looks like. F of x is equal to 2x squared minus 4x minus 1. All right, since I have a 2 up front here, I can't just take these two terms by themselves. I have to factor a 2 out of both of them, because we want just a plain x in my parentheses to complete the square. So now I have to kind of do this, and I need to save a little bit of room here. F of x is equal to 2 times x squared, because if you multiply these together, you get this back. And then what would I need here after that? Well, if I put a negative 2x here, let's see what happens. 2 times negative 2 is negative 4, so that is correct. Plus blank, minus 1, and then now I've got an extra 2 here. And it's really 2 times blank if you think about it. So I need to actually subtract 2 times the blank right here. And I've run out of room. I should have moved it over a little bit, but that's okay. So what goes into blanks? All right, let's find out. So I need to take half of this and square it. Negative 2 over 2 is negative 1. Negative 1 squared is 1. And that's what goes in the blanks. All right. So if I had more room, I would have put parentheses around that right there because that's really close to the edge. I usually don't like doing that, but I ran out of room. All right, so let's see what that looks like. Now I have f of x is equal to, this is now a perfect square, but I still have to put the 2 out front. That's my a value, and the a value always stays the same. Okay, this is now x minus 1 squared. And if you can do this little calculation right here, that's great. If you can't, it's no problem. Minus 1, take away 2 times 1 is 2. So now we have to just clean up the constant here. F of x is equal to 2 times x minus 1 squared minus 3. And there it is right there. And this is my left hand, always fun. All right, so what's our vertex when we turn it into vertex form here? Our vertex is, again, opposite 1, comma, keep this as is, negative 3. So we get the same exact vertex, and I like to do this method. I like to do this method. I usually do this one myself, but this one is always available. So that's example number 2, no problem. All right, so now here comes our boss stage. Example number 3. Example number 3, because you know, of course, I've got to make it more difficult. X squared plus 3x minus 2. All right, the first thing I notice now, since I've done hundreds, perhaps thousands of these, is that I have an odd number here. That means I'm gonna have a fraction. All right, so I mean, like 99 times out of 100, you're going to get a fraction, unless that number is a divisor or something like that. So now, let's take a look at this. Now we have negative b, opposite b over 2a equals, okay, opposite 3, okay, over 2 times 1 equals negative 3 halves. Okay, so that's going to make some people uneasy because they see a fraction. Don't turn that into a decimal, not right now anyways. Just leave it. We can work with fractions, no problem. Let's see how this is going to work. We want now f of negative 3 halves. All right, equals negative 3 halves squared plus 3 times negative 3 halves minus 2. Okay, every one of these little calculations is going to be nothing more than what you did in elementary school, 5th and 6th grade. It's just going to be a couple steps. So negative 3 halves times another negative 3 halves is really going to give you 9 over 4. If you think about it, negative 3 squared is 9. 2 squared is 4. Okay, that's no big deal. 3 times 3 halves, 3 times negative 3 halves, 3 times 3 is 9 over 2. Don't multiply these together. That's a no-no. 9 over 2, and it's negative. So minus 9 over 2 minus 2. Now, what I usually do here is I turn all of these into fractions with a common denominator. 9 over 4 minus, okay, 2 times 2 is 4, 9 times 2 is 18. So rename that minus. Okay, what would 2 be with a 4 in the denominator? Well, to make that simple, you just really multiply them together. 4 times 2, and that gives you the numerator. 4 times 2 is 8. 8 over 4. Okay, so here's where we're at now. 9 minus 18 minus 8. 9 take away 18 is negative 9. Still minus 8. And I can write both of those over 4. And that's equal to negative 9 take away 18, negative 17 over 4. So my vertex, finally, I have, is going to be negative 3 halves, comma, negative 17 over 4. Now, a lot of times they give you questions like this that are multiple choice, or they are I guess, short answer. And you have to actually write this with the fractions in there. And college professors get all bent out of shape if you write decimals, especially if this number, if the fraction does not terminate. If it keeps on going and it repeats, they don't want to see that. They want to just see the fraction. So just leave it. Okay, so now what we're going to do is we're going to graph this. So I have x squared minus 3 halves, or plus 3 halves, 3x minus 2. And if I remember, let's go ahead and flip that over. If I remember, the vertex, and I'll write this up here, the vertex was at negative 3 halves, comma, negative 17 over 4. All right, well, negative 3 halves is easy. That's just 1.5, right? So I'm going to go over negative 1.5 right there. Negative 17 over 4, that number is AKA negative 4.25. Now I'm going to use decimals because decimals are actually easier to graph than fractions, unless you're really good at graphing fractions. So I'm going to go over 1.5 backwards, negative 3 halves, and down 1, 2, 3, 4, and a quarter. Right there. So it is not a lattice point. It does not land on one of these intersections of these grid lines where both of the coordinates are integers. And that happens frequently. So now how do I use my pattern to graph all the other points? Well, I have an a value of 1, which meant over 1 up 1, right? So if I go over 1 up 1, we're looking right there. And if you can kind of keep track of where you're going, it's really no big deal. And if you can't keep track of where you're going, you're going to have to make a table of values, and you're going to have to calculate all these y values by hand or in the calculator or something like that. And it's going to just be a lot of time. So let's see if this works. Over 2 up, 4, right? So 1, 2, 3, 4 right there. Okay, looks good. Over 3 up, 1, 2, 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And if you're close, yeah, it's usually pretty good. All right, I can't really fit another one up on there because 16 is too much. So let's go back the other way. Over 1 up, 1. Over 2 up, 4. Over 3 up, 9. And we see the pattern, and the pattern looks really good. All right, we'll go ahead and connect our dots, points. And there's our graph. So this time, I'm not going to do the completing the square here because it's going to give us the same vertex. You can do that on your own if you want to. It kind of makes the video a little bit too long. But if I get a quadratic that looks like this, this is how I'm generally going to do it anyway. So hope this video helps. Remember to like and share, and remember, check in frequently. Remember to subscribe, and I will see you guys soon. Take care.